Good evening, everyone. Welcome to the resurrection of the Azure Cleveland user group. So as you know, the group was started some time ago, but the leader, Steve Geiger, had stepped down. So I didn't want this effort to go to waste. So I had stepped in and decided to start scheduling meetings. So we're going to need meeting every second, we're going to be meeting every second Wednesday. The meetings will be free of charge and open to the public, as most user group meetings are. And being that it's Azure, it's going to cover a variety of topics related to Azure. So infrastructure as a service, platform as a service, and then software as a service. So we're going to try to target topics related to all three of those subjects. You can find the meeting information posted on meetup.com for both past as well as future meetings. And like we always do, participation is always encouraged, so feel free to jump in with any questions. When not speaking, kindly ask you to mute your microphones just to avoid any background noise, and keep it casual but organized, meaning give a chance to the presenter to go through the slides and the demos, but feel free to jump in at any point in time with any questions or comments. And as we had mentioned earlier, the presentation will be recorded and posted on YouTube, and the link will be made available in chat in just a bit, as well as it'll be posted in the comment section of the Meetup site. So for tonight's feature presentation, we have Jeff Palermo talking about Azure DevOps for .NET, Fall into the Pit of Success. And Jeff is a chief architect for ClearMeasure. He's been a Microsoft MVP since 2006, and he founded and ran several user groups. He's also a national conference speaker at big conferences such as Ignite, TechEd, Visual Studio Live, DevTeach, and a few others. In addition, he's been a repeated author for books, videos, articles, and he hosts one of my favorite podcasts, the Azure DevOps Podcast. So with that, I will turn it over to Jeff, and let me go ahead and make you presenter.
Thank you, Sam, and thank you for your leadership and guiding the group there in Cleveland. And by the way, with these types of talks, I am perfectly comfortable being interrupted with questions. So we've got the verbal chat thing going on. You know, be personal. And then Sam, if you wouldn't mind, if any folks are chatting and there's a question that I need to be interrupted for, you know, just help me out with that.
Absolutely.
So, and actually, while it's on the slide, but I'm actually going to put my email address in the chat right now, because there are a few things where if you would like what I'm showing you, a copy of it, then you can send me an email. I'll also follow up afterwards with any questions. I'm happy to help anybody. Even though I don't know most of you, what I do know is that if you're tuning in for this type of session and you're spending your evening at a user group, then that means you typically like to get more done in software. You like to move faster. You like to produce high quality on whatever project you're on, so you can deliver for your team, your company, and ultimately your customers. And a lot of those concerns are going to be talked about in this presentation, but this presentation is not a redelivery of documentation of every button and knob that you can use inside the Azure DevOps product. And most of you are already users of that product, I would imagine, to some degree. Microsoft does have pretty good documentation on how to use all kinds of features in the product. And so this presentation is about the architectural decisions that you have to make in order to decide which of the buttons and knobs to touch inside of Microsoft's product. So, you know, when you go into the documentation, reading it can help you learn what the product can do. And so my hope is to share with you how to decide why to use a particular feature. You know, with this being a Azure user group, you know, you don't want me to bore you with features anyway. So now a little bit of philosophy to help us get started. I know from experience, and I've been a programmer since 1997, that if you map out your software delivery process and then you automate that process, then you'll deliver more throughput, and you'll absolutely love the result, but also you'll love the process. You'll love programming. Programming will be fun. I talked to so many people who got into programming because it was fun, and you almost forgot to go to bed at night, and you stayed up all night just tinkering and making the computer do interesting things. And then on some projects, it becomes work. So this type of content and this type of presentation is really about liberating the process, because we do have a big problem in our industry as a whole, a pretty serious problem, and a problem that needs to be solved. There's a lot of teams that automate work for their customers by producing a software application, because the software application does automate regular work, but then they saddle themselves with new administrative work. What type of administrative work? Well, the work to build and deploy and then monitor that software that, by the way, relieved the customers of their administrative work. And there's no reason that the old saying, the cobbler's kids shouldn't have shoes. I work with a lot of teams, and it seems like a common theme, where one of their most senior, most capable developers is actually trapped by the task of deploying the software because he's the only one who understands the software the best. So they take their best talent with the most experience with the software and then reduce them to weeks of administrative tasks. Because remember, a deployment is a set of administrative tasks. You copy some files, you change a config file, you configure a credential, you change a setting, you restart a service, you tweak a service, you change a service, you go into the Azure portal, you change something, you restart, you check it, and then you do it over and over and over and over again, swap a slot. It's administrative work. And so many of us got into software because we saw the tremendous power available. We can write the code, make a computer do something that makes our lives easy, others' lives better. So we shouldn't settle for a process that takes people with technical creativity, which is you, and then turns you into a robot just doing mindless tasks over and over. And for I'm sure in this group, in this room, there's probably some managers listening in, and so I wanted to share, for managers, what goes on in the brain of your people who have to do manual processes over and over. We as humans, we're always in the pursuit of happiness. Whether we get fulfillment in serving others or making something new, your people aren't finding happiness in the process of manual builds, environment configuration, and deployment, regardless of what product that you happen to be using in the software or what frameworks or what type of cloud services. They want to get it done as fast as possible so they can get back to why they got into software in the first place, to create things and to solve interesting problems, to make others' lives easier through the software. And as a result of this dynamic and manual tasks being error prone, your staff has to endure this, and it doesn't bring happiness or satisfaction. And as that goes on, they become open to considering maybe other employers that might be able to provide more work that does bring satisfaction. So whether you're an individual developer, whether you lead a team, or whether you're a manager in technology, I hope that you can get something from this presentation. A little bit, just by way of introduction, like Sam said, I am one of the chief architects at ClearMeasure, and we are a software architecture company that focuses on clients with in-house .NET development teams who use Azure for cloud, and that's the primary stack. There's all kinds of other technologies, and there's AWS everywhere, and there's JavaScript everywhere, but the teams that consider themselves to be Microsoft focused development teams, and we help those teams be more capable because our clients typically don't want to outsource their projects. They want to do their projects in-house. So we help those teams become more self-sufficient and kind of up-level their capabilities. Some of my hobbies, my main hobby consists of anything with two wheels. and my son on the left changing a tube. We do kind of an amateur dirt bike racing circuit here in Texas, and actually we have a race coming up this weekend. My daughters race from time to time, but my son's kind of been the most consistent one. And then we live on the outskirts of Austin, Texas, just far enough out where we can graze some longhorn cattle, some donkeys, and have a fairly good sized chicken coop that produces more eggs than we can eat. So that's a little bit about me. And so let's dive in. Let's dive into the content, the topic or the table of contents here, the agenda. Pretty simple. We're going to talk about this challenge of DevOps. We're going to talk about the structure that your pipeline should have, and then we're going to talk about how to start. And there's 7 key stages of the pipeline structure that you need to configure in Azure DevOps services in order to get the most out of the product. But I will say, even though everything that we're talking about here assumes Azure, talks about Azure, assumes Azure pipelines, Azure repos, all the different capabilities of the Azure DevOps system, and it assumes .NET, but these principles and this way of thinking that we're going to talk about, you could apply it to other technologies, other products as well. You can apply it. We've helped customers do it on JetBrains TeamCity, on GitHub. We've integrated Octopus Deploy. So it really is. It's a way of thinking, and because everybody has a different mix of products that are used in your particular development environment. If you care to copy down my email address, I did write a book that launched just a couple years ago called .NET DevOps for Azure. And if you want a electronic PDF copy of that book, then I am more than happy to send it to you on an individual basis. Just send me an email and I can get you a copy of that book. It's up to you. And then also, Sam also mentioned the podcast, and you can go to azuredevops.show or just search for it in any of the podcast directories. And I've also done a little bit of work on a video show called Architect Tips. You could also go to architecttips.clearmeasure.com, might be useful to you. All right, so let's get into the content. 7 key elements of a DevOps environment. We're going to go through each one of them, and of course you look at the first one, and you think, okay, well, where does that fit into Azure DevOps? Well, we're going to talk about it. So we're going to talk about what you do before you even put your hands on the keyboard to write any code, how to track the work through the design process even before you get to the code stage. We're going to talk about how to structure the version control system. Okay, Azure Repos, yep, it's got some great features of Git hosting, and it can host your Git repository. But what I found is a lot of teams struggle with what the structure of that source control repository should be. So we're going to talk about that. We're going to talk about what builds you need. Not just, I mean, yes, Azure Pipelines does a great job running builds, but what builds do we need? What should those builds be doing? We'll talk about that. We'll talk about full system testing. We'll talk about user experience testing, where that fits in. We'll talk about how to actually release to production and decide when to do that and track that. And then we'll talk about observing the application through telemetry. So let's get into our first analogy. All right. So on the screen, you kind of see a little bit's being cut off, but you see some water flowing out of a pipe, and you see a pipeline. The DevOps pipeline can be thought of as a water pipeline. It's a really good analogy, and this is why. What you expect from a pipeline that's carrying water is the same thing that you expect from a development environment pipeline that's carrying changes to the software. You want smooth flow. You want to filter out impurities so that you don't end up with dirty water or buggy features coming out the other end. And you need to measure those two things. Now, for water, there's water pressure, gallons per minute. That's the corollary to throughput. How many changes, how many new features are going down the pipeline of your development environment? And then you also need to measure water quality, impurities on software. These are bugs. It's not okay to turn on the sink in your kitchen and no water comes out, or drip, drip, drip. And then all of a sudden it's blasting at you, just getting all over the place like a fire hydrant. You want it to be consistent and predictable and the right water pressure. You want the water pressure that you can consume. And same thing with software. You want a consistent flow. Now, I recognize that about half of the developers in our industry today got into the industry around 2014, 2015, because just looking at the growth metrics that we've seen of developer surveys, we've had an explosion of growth in the software industry, and we have twice as many developers than we did 7, 8 years ago. And so if you think, okay, expand that statistic, then half of the developers joined the industry after 2014, 2015, and then half joined before. And I think we're continuing to accelerate growth according to some numbers that I saw, but I haven't updated those numbers in the last 6 months. So some of the conversations that happened before 2014, 2015, industry-wide, need to be had again. And one of those conversations is around chunking up of a development cycle. And there's a lot of teams that use Scrum, and Scrum, there was tons of discussions about chunking up iterations, or in Scrum called sprints, versus larger phases. And everyone has gotten away from really large multi-month development phases where you go many weeks without a single deployment to any environment. Pretty much everybody's gotten away from that. That's old news. But there's still discussion about how frequently we should deploy, not just to the production, but deploy to an internal pre-production environment. And that decision pretty much dictates the type of process that you're going to choose for your team from a cycle perspective. And so what we found works pretty well is to choose a pretty small organizational cycle, and 1 week is really common, but don't tie the DevOps automation to that cycle. Enable single piece flow, which the Kanban processes have pushed for the build and test and deployment automation, so that even if you are at the beginning of a weekly cycle from a kind of tracking work perspective and a project management perspective, you should be able to take a single change and finish it in the code, and then be able to just push that on through to production. And a lot of companies that run online properties have adopted that type of process. And so we need to make sure that we're tracking work in Azure DevOps in the way that supports that, and that we have automation that allows us to operate on individual branches for individual changes. And so we'll look at that a little bit. Now we're going to dive in, but I wanted to show, this is the top third. It's a highly shrunken technical blueprint for the structure and flow of a pipeline that's implemented with Azure DevOps services, as well as some other really popular products in the industry like Redgate for SQL Server, and Octopus Deploy for more sophistication around deployments. And it has continuous integration with a 3-tier deployment pipeline. If anybody is interested in the high resolution copy of this poster, then just send me, this is the full poster, send me an email and I can send this to you. I know you can't read it here, and we're not going to go into every bit of it. We're going to highlight some of these aspects, but it's meant to be printed on 2-foot by 3-foot poster board. But if you just want the high resolution PDF of this DevOps architecture poster, I'd be happy to get it to you. And I am going to highlight the fact that Azure DevOps Services rarely stands completely by itself in a vacuum. It's so common to pair it with, to marry it up with other products in the marketplace, and use Azure DevOps Services as the brain, but then bolt on other products. That's very common. And Redgate certainly has top tier. It is the industry leader for commercial SQL Server schema management and data management capabilities. One of the really awesome capabilities that Redgate has is SQL Data Mask and SQL Data Generator for your deployments, because oftentimes we want that production-like set of data, but we don't want actual production data that has sensitive information. And so the Redgate products, one of the things they do is with SQL Data Mask and SQL Clone is we can clone a database from a production backup, but use a configuration in SQL Mask to basically anonymize and strip out any sensitive information from that database backup, so that we get the right structure and ratio of different table sizes and the shape of the data, but we transform it into a non-production format that can be used, and it provides automation. So on demand, we can refresh pre-production environments, and also snapshot pre-production environments, so we can do big test cases and then just press a button and reset that database to a known state. But I digress. I don't want to do a commercial about Redgate, but Octopus Deploy, for very simple applications that just deploy, you don't need Octopus Deploy if you're using Azure DevOps Services. However, you do start to hit a wall with some of the more complicated deployment scenarios if you only are using Azure pipelines. And so Octopus Deploy, it supports the most complicated of deployment scenarios, and all kinds of capabilities for maintaining and monitoring your infrastructure. And so it's very common for Octopus Deploy to be married up with Azure pipelines for people that grow into that. Whenever they look at Azure pipelines and say, man, it's starting to get really complicated, then you just kind of configure it with Octopus Deploy, and then everything becomes simple again because of Octopus Deploy's huge sophistication in that area. All right, so just send me an email if you'd like to copy the poster. All right, so we're in the pre-code design process. We're going to focus on the top row of this particular flow. So if we think about the overall process, there's 4 types of design decisions that we have to make before we put our hands on the keyboard, before we write any code, whether it's a new feature that we're adding to the code base or whether it's a change to the application. We still have to go through these 4 decisions. If we ignore any of these 4 decisions, then invariably a developer is going to be sitting at the keyboard, motivated to make this change to the software, and is going to be confronted with the fact that there is a gap in understanding on what to do. All right. And depending on experience level, depending on personality or propensity for stopping and going and having a conversation, you're going to get different assumptions that the developer makes because hands are on the keyboard. And so let's go through those 4 design decisions, and that's the top row here. And we'll go one by one. All right, conceptual definition is the first bit. This used to really commonly be called requirements gathering. And that's basically understanding the vision or understanding the goal of a particular feature or software change. What are we trying to accomplish, really? Let's get a clear understanding for what we're trying to accomplish, the situation, the scenario, the types of customers, so that we can understand the goal, the concept. And by the way, if you want to use, if you don't like the names that I've given to any of these phases, pick your own name. I don't care. but just make sure that you have each of these 4 types of decisions when you put together your process using Azure Repos. And Azure Board, we'll talk about how to configure, how you should be configuring the columns in your board in just a second. But once we understand the general concept of what we're trying to accomplish, then we need to make design decisions around how a person is going to use or experience the change that we're going to make. Okay. Now, obviously, if the new feature or the change is on a screen, then there's going to be a visual element that they're going to click on some buttons, they're going to interact with the software in some way, whether it's a handheld, smartphone, desktop software, web, whether it's behind a bot where you're just talking to the software and it's doing something, or it could be a completely headless behind the scenes process that just moves data from point A to point B. Every bit of behavior in the software has a user experience. It doesn't have to be visual. And so let's just take the feature that moves data from point A to point B. The decision about how long the software has to move that data is part of the user experience. It's a very different user experience to have the data be moved and be fresh to within maybe 1 second or 5 seconds than to have the data be fresh every 6 or 12 hours in a big batch job format. That is a user experience decision. How should a person experience this? What does the person need from this new feature or this change in the software? So that is a design decision. And obviously, visual things, you need wireframes, so that goes into there. But everything around how a person is going to use and experience that change goes into this stage. The next stage is technical design, and that's where architectural decisions, framework decisions, language decisions, what NuGet packages, commercial or open source libraries we're going to use, what design patterns we're going to use, any changes to a database schema, or if we store data in any kind of fashion in Azure Blob Storage or Azure Service Bus with queues or topics or subscriptions. If we're going to use SignalR for non-guaranteed synchronous real-time messaging, or are we going to use more of the asynchronous guaranteed delivery that Azure Service Bus gives us, or if we're going to use blocking calls, web services from component A to component B. All that's a part of technical design. And when you're building a new component in a system or a net new application, certainly you're going to make some of the big architectural decisions like what programming languages and major libraries and all that. But as you get down along the way, and maybe you're just adding one field to an existing screen, well, the decisions around the conceptual definition, that's going to be a quick design decision. Hey, we need to add this field because we need to track a new data point. It's going to be quick. And then it moves on to user experience. And really the design decision is, where should the field go? Should it be at the top of the screen, or should it be after field A but before field C? But that'll be quick as well because it's a smaller change. And in technical design, it's not going to be big architectural decisions that you're going through. It's going to be small things like we have a table that needs a new column in the table. What should the data type be? Should it be in varchar? Okay. Should it be length 20? Should it be length 30? That's the decision to make there. And for existing databases, should it be non-null by default? Is it nullable? Okay, if it's non-null by default, what should the default value be for records that don't have this? I mean, but they are technical decisions, okay? So you need to make those technical decisions, whatever they're going to be. And certainly features that cause you to introduce a new architectural element to the code base are going to have more work to move past this phase than just making a quick change to an existing screen, especially styling changes that may only be a CSS style sheet or whatnot. Those go through pretty quick, and it's perfectly acceptable to forward something along saying, oh, there's no new technical decisions that or new architectural elements need to be added into this, but a confirmation that the existing architecture is sufficient, the existing norms, the existing team standards in this code base are sufficient for this change to be made, like, hey, change the color of, particular item in a style sheet. And then the acceptance criteria or the test design, that is the last design decision that needs to be made before before code can be written. And the best format for acceptance criteria is a list of test scenarios. It really is. Again, teams that like to use concepts from Scrum call it a definition of done, just to make sure that we know when we're going to be finished. Well, the best format for writing those things down is a test scenario or a test case. And every change to software, invariably, if it has behavior, if someone's going to click on a button, there's a happy path where it does the right thing. But there's also an exception path where, hey, maybe they didn't fill in some required fields and they hit the button. What should happen? Well, it shouldn't execute a transaction because we're not ready. They missed some required fields. And so there's an exception path. A lot of features have multiple exception paths. And so we need to enumerate those, because if we don't enumerate all of the different branches of behavior that this change needs to cover, again, we're going to be relying on the personality or the type of experience of the developer that happens to be working on this item, and we're going to get non-deterministic results out of that. And so we as a team, we want to make sure that we enumerate all the different things to check. If a developer says, hey, all the code's written, this is done, okay, how do we validate that real quickly? We need an initial checklist to just go through and say, hey, can you show it to me? Well, what are you going to show me? Are you going to show me one thing, two things, three things? So those are the design decisions that need to be made. Now, if we go to Azure Repos, we need to lay these out on the board. And Azure Repos has a history as iterative, the iterative Agile template and the Scrum template and the CMMI template, but really, I think that a lot of people, and especially people using Jira and some of the work tracking software that's been around, during the big discussions of the Agile software transformation in our industry, they have way too many features, and Azure Repos has way too many features. And so what Microsoft did a number of years ago was add a basic template, and the basic template, it has epics and issues. And really, with the acquisition of GitHub, they kind of realized, oh yeah, we really don't need, or most teams just don't need all that complexity. And GitHub has just issues, and users of GitHub for their work tracking are perfectly happy just using issues. Oh, issues for a feature, issues for a change, issues for a bug. And so, actually, my favorite template in Azure Repos is the basic template, because then we can just use issues. Now, it does have a built-in segmentation, parent-child segmentation from issues to tasks. So you can break up an issue into tasks. And I find that very most aligned with, if you just translate in your mind, to development tasks. So this is a board of what, and by the way, this is expanded in chapter 4 of my book, but you notice the first 4 columns are the design decisions. The work that we're doing in those first 4 columns is not in the code. Now, in technical design, if we have existing code, then whoever is working on that, maybe prototyping on a side branch, maybe prototyping a new pattern, or maybe a sample implementation, how we would do something, that's fine too, but that's throwaway code. We need to start tracking where the work is at the very beginning. So a mistake that some teams make is only starting to track the work on a board when we're ready to actually start with code. And then we think, then we go from idea to code without really enumerating a lot of work that has to happen before, which is defining the concept and the user experience and the technical design and the test design. And so each of these columns, as it goes through, the person working on that should be adding more and more information to that work item. to that story card. And then in technical design, what we found is it's a very natural flow for, and whatever title you have, the person could, some teams, have dedicated architects, they have lead engineers, or they just rotate some of the senior engineers to do the technical design. But whoever you have working in the technical design column, as they're identifying the appropriate way to implement whatever the change is, to start enumerating the tasks underneath that card as child elements, and effectively we have a checklist of implementation for that particular card. And then in development, we kind of provide guidance for the developers. Now, very, very small teams are just going to move around very fluidly, but as you have larger teams, it's more and more important to designate the people who are going to be making these technical design decisions and breaking up the work into implementable chunks, and the people who are going to be taking the implementable chunks as a queue of work and just jamming out the code. All right. And of course, it's a judgment call of what size your team is and what size it really becomes necessary. But what I've witnessed is if you're a team of, even a team of 10, you really, really benefit from segmenting those job responsibilities and doing that there. All right, and let's go on and let's go to the next stage, which is the version control system and the structure of that. So we have Git repositories. I'm not really going to talk about anything other than Git repositories because it's pretty much become industry standard right now. But let's talk about the source code structure for any particular software system. So regardless of the architectural or the archetypical pattern that you use for a software system, you are going to break it down into many pieces, many applications, okay? And when I say application, I'm talking about something that can be deployed as a running process. And I understand that a particular application sometimes has multiple running processes. Well, let's take the new Blazor WebAssembly in .NET 6. There's a Blazor WebAssembly process that runs in your browser, and then there's a web API project that runs on your server, and then there's just say a SQL Server database. So one application has 3 running processes, one for the browser, one for a server, and one for database. Okay, so that's perfectly fine. But large software systems, it's normal to segment them into many versioned software applications and have those have different deployment schedules, completely different, possibly different architectural patterns or whatnot. So that's normal. The important part to remember, the key, the rule of thumb that you're going to be hurting if you violate this. You're going to constantly be working around it. Is if you put more than one versioned software application in a single Git repository. And we do see teams making that mistake. And then every bit of their build, test, and deployment configuration downstream from that is constantly compensating for the fact that they have multiple versioned software applications in a single Git repository. All of the products in the DevOps space and the deployment space are primarily designed and tested with the assumption that we are operating on whatever is in the Git repository. We're gonna run a build process on what code? The code in the Git repository. We're gonna run tests on that. We're gonna deploy what came from the Git repository. And if you break that rule, then you're going to be rolling your own configuration a lot just to try to, tell all those products, no, don't worry about what's in my Git repository. Only worry about part of what's in my Git repository. So, and typically a version software application is one Visual Studio solution. Again, it's fine to have multiple projects where you have multiple, in order to deploy it, you deploy multiple running processes, but altogether it is one logical software application architecturally. All right, so that's important. Now let's talk about builds. This is super, super important. Continuous integration. And this is, again, half of our industry, half of the developers in our industry were not around for all of the arguments that the industry had when talking about what continuous integration is, what integration is, how frequently we should be doing it, which is where the word continuous came from, and then what the heck that even means. And if you just pull out Azure pipelines and go through the documentation, the product will cause you to do a compilation against a Visual Studio solution that happens to be in a Git repository, and then you add on, tasks, and okay, you can run some tests against projects in there, and that'll, you can get an automatically triggered build. That's great. That's 1/3 of continuous integration. And so back in 2006, there was a book. You can get it from Addison Wesley Publishers, and the book is literally called, the title is Continuous Integration. So if you've never read that book, or you didn't know it existed, I highly encourage you to go and read that book and look at just the main parts of continuous integration. And I'll just break it down for you. I'm grossly simplifying it, but the 3 parts of continuous integration are the private build, what happens on your individual developer workstation, the integration or team build, what happens on a shared team build environment, and then third is the first deployment. That's continuous integration. And the reason that there are 3 key stages to continuous integration is because they answer distinct questions about the suitability of the code base to be given out to anyone. And so the private build is first, and the private build doesn't even require a network connection. You could totally disconnect from Wi-Fi, unplug your cable, and you should be able to do everything in the private build. And that's where it doesn't even matter if you're using Azure pipelines, because your code base should be equipped with a private build that's just a PowerShell script. And what it does is answer the question, with the change that I just made locally on the branch, on the feature branch that I'm working on, completely isolated to myself, did the change that I just made destabilize the code base? Or is this code base still as stable as it was when I started working? Okay, that's the question that it answers, because obviously, if it's not as stable as it was when I first started working, then it's a waste of time for me to go on to the next phase and do a team level integration build where I start interacting with my teammates, because I'm just making the software worse. In medicine, the Hippocratic Oath for doctors is first, do no harm. It's the same thing with developers. You get a code base that's in a certain condition, certain level of stability. First, do no harm. Don't make it worse. All right. It's better to not change anything than it is to change something and make it worse and introduce a bug and break something. So the private build answers the question, with the change I just made, is the software still as stable as it was when I first started working? All right. If the answer is yes, then we go along and we commit to the Git repository. And on our branch, we want to configure the integration build first on our feature branch. And now there's some teams that commit directly to master, and that's perfectly fine. You can have the integration build operate on whatever branch it is. So a lot of teams, I'll go into pull requests later, but the integration build works on a shared build environment, and the question that it answers, because you're committing code into a branch that other developers are committing into as well, and it says, with what you just changed, mixed in with all of the other recent changes from the other team members, does the combined result, is the combined result still as stable as it was before you integrated your changes into that mix, or did something break? Did something destabilize? Do we have a new bug? Okay, that's the question that it answers on the team level. All right. And if the answer is no, obviously you want to roll back your changes, work on it, and then try again. All right, so that's the second question. The third phase is that first deployment. And without answering that question, you don't know if the build that you just made is actually ready to be shared with anyone in your company or any of your customers. And you do not want to be testing your deployment and configuration logic and changes to that logic for the first time when you're trying to give it to somebody, whether it's a production customer or whether it's an internal customer. You just don't want to be doing that. So the last stage of continuous integration is that first deployment of that new build. And the question that it answers is, does this build, which resulted of multiple changes from multiple people, does this particular build still deploy to its intended environment properly? Does it still start up properly? Does it still use the proper configuration? Does every component in this particular application still talk to each other and talk to the different parts properly? Or does this build introduce an issue? So in a deployed fashion to its intended environment, is this software still as stable as the previous build that was deployed just before? And of course, if the answer is no, it doesn't make sense to deploy to a manual test environment or give it to an actual real person. Okay. Now, a lot of the confusion here is when we think deployment, a lot of people think an environment that somebody outside of the development team uses. And I'll talk about environments in just a minute. But let me come back to the first two phases. The private build, the integration build. The difference is where they run and who they're for. Private build is for an individual developer on their workstation only. The integration build is for the team, and it runs on a team shared environment. And Azure Pipelines is fantastic about the hosted build agents. And if you have specific dependencies that Microsoft is just not going to install, you got two choices. You can use Chocolatey to install those dependencies on the first run, or you can set up your own VMs to run those builds. It's your choice. But typically, you want it to go through the same set of steps. You want it to run through some type of clean process to make sure that everything is in a known similar state. You want to stamp your build number as a version number in the software so it can be compiled into every assembly. Then you want to migrate whatever data structure you have. Certainly, SQL Server databases. Okay, if there was a new column, well, we need to build up a database suitable for running tests as a part of the build process. And now that our environment is set up, we want to compile all that C# code, then run unit tests, which, by the way, unit tests do not call out a process. Then we want to run component level integration tests. And those will include your entity framework tests that call out to the SQL Server database and whatnot. And then after that, we want to run static code analysis. We want to publish the test results, package up our application components for deployment, and then finish and publish that new release candidate to Azure Repos. There are two ways to archive results of a build process. One is with the build attachments, and that was the original feature set. I don't recommend using that anymore. I recommend using the Azure Artifacts service. That is a NuGet server. It's an internal NuGet server. And the best format for a deployable package for a Visual Studio project and its dependencies is a NuGet package. Now, with the Azure Container Service, the deployment package for those, well, that's changing, and the deployment package for those will be the container. And with .NET 6 and with so many new processes where, we don't care what operating system it runs on, the de facto more and more is actually going to be running on Linux in Azure Container Apps, which actually is running on a Kubernetes cluster, but we don't care about that because it's made the experience just as simple as app service. We have a very nice and streamlined service in Azure that we can just basically throw a container at it, and Azure says, thank you for your container. Shall I run it for you? And you say, yes, please. And it just runs however many instances of the container. You don't even have to worry about server size like you do in app service. So that's a pretty cool service that is not GA just yet from what I've seen, but we've done some internal tests and it's going to be great. But, all right, let's talk about from build, the release candidate portion. There is a mapping of your Visual Studio solution to deployment packages in Azure Repos. And if you think about it, if you have a ASP.NET web project, whether it's Blazor or what, it doesn't matter what flavor of technology, it's a web application of some sort. You need a package that is suitable for deploying to app services or Azure Container Apps or whatever you're targeting it for. If your application has an offline job of some sort, whether it's some handlers for an Azure Queue or Azure Service Bus subscription, there's some type of offline job, that needs to be in a separate package because it has a different target. Maybe you're deploying it to App Service or Azure Functions or whatnot. And then, of course, your SQL Server database schema, it needs to be packaged up in a format because it's going to be run against Azure SQL, whether it's managed instances, whether it's serverless. You need to have a separate package. And then don't forget, your acceptance tests need to be packaged up and deployed because there are tests that require a fully deployed instance of your entire application in order to be run. And I'm talking about your level 2 tests. So, Microsoft has documentation around level 0, level 1, level 2 tests. Level 0 is your unit test. Level 1 is your component level integration test. And level 2 tests are full system tests. Whether it's Selenium or Cypress or Playwright, these actually drive your application from a user's perspective. Even pulling in either a Chrome browser or in the case of Playwright, a headless browser, and actually clicking on buttons and typing in text boxes. In the case of Xamarin Test Studio, it's spinning up your application on an actual smartphone and clicking on, tapping on buttons on the screen. It's actually driving it like a real person would. Well, guess what? You have to deploy to a representative environment in order to run those types of tests. So for those types of tests, those tests need to be packaged up in a release candidate package and deployed to the environment so that your automation knows what version of the test suite to run against the matching version in that environment. We like to call that particular environment the TDD environment, which stands for test-driven development, invoking that type of mindset. And so here's that flow depicted. The continuous integration build, upon success, pushes out a release candidate, which is a set of packages, all marked with the same version number, one package per deployable application component, and they're all stored in Azure Artifacts, which is a NuGet server. And the deployment logic, whether you just use the steps that are built into Azure pipelines, or whether you use Octopus Deploy, or whether you jam out your own script, it doesn't even matter. That logic needs to go to Azure Artifacts, which is a NuGet server, grab the appropriate version number, and do the deployment. And so, depending on how many environments you have, you still do the same thing. You go to Azure Artifacts, you deploy to that environment. You go to Azure Artifacts, when it's time to go to production, the automation should go to Azure Artifacts, get the right version, and deploy to production. I've heard people say, I need to build to UAT, or it's time to build to production. And in that case, they have the automation actually go to the Git repository, compile the code again, package it again, configure it again, poke in settings again, and then go to production. Well, you're basically creating on demand a release candidate that has not been tested. And so in order to tighten that down, limit the surface area of problems, We want the production environment to actually take the exact release candidate that was deployed to the TDD environment, had full system tests run against it, then was promoted to the UAT environment. Real humans did some stuff and poked around and gave it the thumbs up. And now we go to production. We are limiting the surface area where bugs can creep in. And so that's really, really important. Now, I will say in any particular applications DevOps pipeline, you have a minimum of 3 environments. This is the smallest number that you'll ever have. Now, a lot of teams have many, many more. That's great. But you'll never have fewer than 3. And that's because there are 3 distinct types of environment, and you need one of each. You need at least one of each. You can have multiple of each, but you need at least one of each. Everybody knows production. It's what your customers use, and you need at least one of each. There's some architectures that really need multiple production environments, whether it's for a hot backup, whether they shard and segment customers on different production environments, but you need at least one production environment. Backing up from that, you need at least one manual test environment. I think the most common name for a manual test environment is UAT, stands for user acceptance testing. You need at least one of those. That's where a real person can use the software and make sure that it meets the need. You need at least one of those. So many teams have many, many, many manual test environments, and that's great. I mean, common names like dev, test, sit, dit, staging. There's so many names for manual test environments. And yes, I threw in dev as part of that. The typical dev environment, the common use of the name, is an environment for the development team where they do manual testing, where developers can go in themselves and do some manual testing. So dev is one of the manual test environments. The TDD environment is the environment type that we see lacking so much. And that is the type of environment that is designed specifically for fully deployed tests. And it doesn't make any sense for a real person to ever go in and use the application that's deployed to the TDD environment, because as soon as the test suite's complete on that application version, the automation just throws away the application, grabs the next build, automatically deploys the new build, and then runs the test suite again on the new build. So if a human were to try to use that environment, it's just constantly getting ripped out from under them, because that type of environment is just for the test automation, and it serves the last step in a continuous integration implementation. And so that it can answer the question, hey, do you have a release candidate that's ready to be deployed? Okay. All right. Now, in Azure Pipelines, this
Hey,
is
Jeff, could I interrupt you for a second?
Absolutely. Go ahead.
If you could go back to the previous slide for a moment.
Yep.
So let's say that we have a scenario where we deployed out to the dev environment, the devs tested it, it worked fine. It moved to QA and user acceptance testing. And then at the final stage of user acceptance testing, a bug was found. Whether it be a big bug or a small bug. But once it's resolved, do you foresee that it should go through all the stages of testing again, or do you think it just resolve that bug and push to production?
My answer is yes. So you found a bug. Let's say everything else was great, and I mean I'm not control. You found a bug, and let's say that the bug was that a field is supposed to support 20 characters, but it only supports 15. All right, let me just give you that as an example. It's a bug. It has to be fixed, right? So you've identified the bug. So chances are there are other branches and other code that's been changed after this particular version came on through. So you can't fix the bug in the head of the master branch. Otherwise, now you have other changes that you didn't intend as you were planning this release. So what you need to do is you need to have a bug branch from the commit revision on the master branch that produced this particular release candidate. And so you're branching from that exact code. You fix the bug, you lengthen the field, whatever it takes to fix the bug, and then yes, you go through the same process, but because that process has only this tiny change, that release candidate gets right back to user acceptance testing very, very quickly. But you still go through the same step. And the full system test automation in your TDD environment, well, that's just a matter of waiting for that test suite to complete. Now, I get that if you're in a production hotfix scenario where it's urgency, some people make the judgment call to assume that the test suite is going to complete, and they just kind of force it to go along. And find, you're always going to make those judgment calls. But if you're not in an emergency situation, okay, wait a couple hours, let it complete. That doesn't mean that you can't forward that deployment onto the appropriate manual test environment so that you can do the manual testing in series, in parallel. That's perfectly fine. But you don't want to not do one of the steps, because invariably, not every time, but invariably, something will happen and you'll accidentally deploy a bug to production, which every bit of this is designed to not deliver bugs to our customers. So that's my best answer for you.
And I completely agree. I would even go to the extra step of saying that even if a developer was working in a silo by him or herself, just fixing one small bug, I think it's best to go through that entire process again, because one change or one bug fix could have affected something else. So it's always best to go through the whole process again. But thank you for confirming what I had believed, and I appreciate your answer on that.
Sure. Yeah, I think the key too, and I see a lot of people making this mistake, is that if they don't have an organized, I see some teams not having an organized branching strategy, and they're just either they're not used to using branches, or they don't use branches in a consistent manner as a team. A bug comes up, they go back to fix it, but then they just wrongly assume that there will not be any other bugs in the new changes that got added into the master branch in the meantime. And so then they either skip the testing of the new code because they assumed, oh, surely there won't be any bugs in these new changes, and then they fast track some bugs right into production, or they took what could be a really fast fix of just a single bug when we were ready to deploy to production, and they slow it down because they added more scope to it.
Gotcha. Thank you.
All right. Okay, so this is what Azure Pipelines looks like from the simplest you will ever get. And you want these in series. As you look at the stages in the product, and I think the product, they made some screen changes, that since I took this screenshot, but the key here, when you look at your stages, whether it's the minimum of 3 or whether you have multiple manual test environments and you have more, you want to see that horizontal line connecting the environments. That means that you have sequenced these steps. Now, if you see the continuous deployment, which is an unfortunate word instead of continuous integration, but if you see that on the left, and then all of your environments stacked on top of each other on the right-hand side, that means that you haven't given yourself a pipeline. You've instead given yourself a bathtub, okay? So you want to make sure you have a DevOps pipeline, not a DevOps bathtub. Because if they're stacked all on top of each other, that means that a person, you're not really automating the sequence. A person has to come in and say, I've got all these environments to pick from. What environment should I pick through next? So make sure you have a pipeline, not a bathtub. All right, now I'm intentionally showing the visual designer on this rather than the YAML, just for illustration purposes. I think it's easier to follow. But anytime you deploy using Azure Pipelines, you want to use the same pattern. Regardless of how many deployable components the application has, you want to use the same pattern. And the pattern is package, config, copy files, package, config, copy files. Let me walk through. So we'll ignore the first one, which is a release annotation. Although I like to do that for every deployment because as we'll get to in telemetry, we want to know when we're looking at metrics from our application when deployments actually happened, so that when the graphs of the metrics start changing, we can correlate that to a particular release number. Okay, but let's skip that just for now, and let's talk about deploying the simplest of architectures, where we literally have a SQL Server database and a web application on the server that calls the SQL Server database. Well, in that case, we would obtain the package for the database, the NuGet package from Azure Artifacts. And then we would do some environment configuration. So in Azure, we can create resources on demand, use the ARM templates, or you can use Terraform, whatever you want to create the resources in Azure, configure the resources in Azure, however many steps it takes, but that's what you're going to do to be ready to actually deploy the database. All right, so this is environment creation, environment configuration. And by the way, this is the same thinking regardless if you're using serverless cloud resources, or whether you're using virtual servers, or whether you're using the Azure Kubernetes service or Azure Container Apps, or regardless of what flavor of service you're using, there's always something that you need to do to configure the cloud service to be ready to accept your application component. All right, so you do that stuff. Then you actually deploy the database. And in this case, we're just calling a PowerShell task that calls our database migration tool, which effectively just looks, oh, does the database exist? Okay, run these incremental change scripts to add a couple columns or expand a field. Or if you're in the TDD environment and it doesn't exist at all because we create it new every time, oh, it doesn't exist. And then your migration tool will create the database and execute every script to create every table and everything in your database. So that's that. Now the database is deployed. Great. That's one of the deployable components. The next deployable component is the web application. And we do the same process. We go to Azure Repos, we get the deployable package that's in there that's a part of this version's release candidate. Then we do some stuff to configure the Azure App Service to make it ready to receive our application. That's the just create test website. A lot of configuration can be packed into that. And then we actually deploy and start it up. Start is a second step from deploy. That's fine. But we actually push our application, copy the files, push our application out there, and now it's done. Okay, now that we've deployed all of the deployable components of the application, and again, if you had an offline batch job of some sort, then you would do this pattern again because you now have another deployable component of that application. But now that you're done, guess what? You want to test it. We are test-driven development through and through. You've done something, you've pushed out your application. Now you want to actually ask the application, are you there? And so that's where we have a self-health check. Now, a health check, you want to do it for every application type. And in order to know if the deployment was successful, you don't rely on Azure Pipelines to tell you it was successful because it doesn't actually know. The only thing Azure Pipelines can tell you is, I executed all these tasks and none of them raised an exception. That's really all Azure Pipelines knows. It doesn't know if your application came up. It doesn't know if your application is connected. It doesn't know if the connection string was right and your web application can actually talk to the database. It doesn't know if the firewall rules were right and you can actually get out and call some other system that you integrate with. It doesn't know any of that stuff. All right, so we need to ask Azure Pipelines to call out to our application now that it's deployed and started up and say, hey, are you there? Are you happy? And that could be as simple as a dedicated hidden web service. And I like to have the URL, my application URL / health check, something simple like that, some convention, same in every environment. You can call it in your browser if you want to. And by the way, I also like to have another web service that is /version. And all it does is it looked at the current executing assembly, looks for the version number, and then spits it out back to the screen so that at any time we can have automation or just in our browser, hey, I'm on a particular environment. Let me just check what version is here, okay? Those are little tips there. But you want the health check to call out to this web service, and then the C# code in that web API controller, all it does is just tickle the key dependencies, just a couple lines of code. Maybe call a very, very simple select statement that's already in your data layer, in your data access project, and execute a super simple select statement that causes the logic to round trip to your database. And because if the connection string is jacked up, it won't be able to get to the database. Or if you integrate with some other system, can you even call out to that system? So a few lines of code to just do a quick round trip to all of the key dependencies. And then if everything checks out, you return status code 200 and we're good. And now we deploy and we verified that the application actually deployed correctly, actually started up, and is happy, is healthy. All right, we want to do that. Now that the application is healthy, guess what? We can run, we're in the TDD environment, we can run our full system test suite. And so in order to deploy our full system test suite, we do the same thing. We download the package for the full system test suite. We do some environment configurations. It's very common to have to inject some variables into the config files of the test suite so that the test suite knows what environment to point itself towards. And then we use the VS test task to run our in-unit tests or X-unit tests or whatever they are. And of course, we want those to pass. And then in a TDD environment, for budget reasons, it's super common just to delete the entire resource group that the environment exists in. Because once we have the answer that all of our tests either passed or failed, we don't need this environment anymore. We don't need this version deployed anywhere anymore. So there it is. All right. I talked about branching briefly. And really, this is why. Feature branching allows you to do formal inspections in a code team. And there's Capers-Jones is probably the most prolific publisher of research in the software industry going back decades. All of his research points to 3 quality control techniques that reliably make a team's quality top tier. And one of them is testing. And so the multi-tiers of automated testing and your manual testing in UAT, that satisfies that. The second is static code analysis, which fits really, really nicely in your integration build. So SonarQube, Independ, definitely the Roslyn analyzers, those are all static code analysis. You want to have that automatically running, finding problems. And then third is formal inspections. And the most streamlined, where formal inspections fit the best is inside of a pull request. And so how do you do a pull request? Well, have developers make literally every change on a short-lived feature branch, and then configure the integration build to also run on feature branches, and configure the deployment to TDD to run off of beta builds that are non-releasable release candidates that are created from feature branches. So you get the full deployment off of what's created off the feature branch. And then once everything's great, the test suite runs and succeeds in the TDD environment, then the developer can create and submit a pull request, which is a request to pull into master. And so in the review of the pull request, all your team has to do is create a checklist so that you can agree what types of things you're going to check in order to hit that approve button. And a lot of teams, unfortunately, have a pull request be just an administrative task of, hey, I've got a pull request, and okay, boom, hit go. Or let me look to see if we followed the coding conventions. But no, a team needs to have a checklist. For example, if you're making the technical design decisions ahead of code, well, guess what? Did we actually implement the decisions that we specified, or are the variances, well known and agreed upon as a team? Also, for completeness, did all of the static code analysis come through without any new problems. Whatever your checklist is, by hitting the approve button on a pull request, your team member is saying, on my reputation, I have verified that the changes represented here conform to every item on the checklist that our team has agreed upon. And I'm going to hit that button, hit approve. Okay. You've just done a formal inspection. All right. I mean, pilots that are flying commercial airliners, they do formal inspections pre-flight, mid-flight, pre-landing, after landing. And guess what? All it is just reading through a checklist. All right. That's it. All right. So let's review the different environments and what to do on each one. In production, we want to do the least bit possible in order to deploy out to production. And as long as we've done the most possible in environments leading up to production, then we don't need to do a whole lot of things. But we don't want to do anything in production that we haven't done in environments leading up to production. We don't want to do anything new in production. We want to do all the new stuff in the previous environments. Okay. All right. Now, let's talk about a feature that's not very, it is a feature, but I think other tools have this feature as well. I don't see this used enough, and that is test attachments. XUnit, InUnit, all the test frameworks have the ability for file attachments to test results. And when you're running full system tests with Selenium or Playwright or whatnot, the best practice is every time you do any interaction with the screen, take a screenshot, save it as an image file, and attach it to that test case as an attachment. And then when you're reviewing the test results, you have all kinds of screenshots. Basically, your test suite narrates everything that this test suite is doing across your application in screenshots. Now, when the tests are passing, you're not going to review the screenshots, but as soon as one of those tests fails, you're going to be able to review it and see exactly what the screen looked like, and it's going to help you reproduce that bug really, really fast. And so you can see on the right-hand side of this is just a web form with a couple text boxes and a button, because the inside of a web browser, that's what we take the screenshot of. And so having that visual representation of what the screen looked like while the test was running is going to save you a whole lot of time. So I don't care how you're running your tests, make sure that your full system tests that are driving the entire application take screenshots of what it looks like on every step. And it's so easy to do. Storage is cheap. That is a best practice for running full system tests. All right, let's close up with telemetry. Everybody has logs. That's great. But when you're running in a automated DevOps environment, especially in the cloud, you need more than just logs. You need full-on telemetry. And we elevate logs to telemetry by adding in metrics and events. And I'm gonna talk about them, but let me talk about how to think about this first. So we showed how we go from Visual Studio to deployed components in Azure. And so in this simple architecture, you've got 4 different deployed processes running in Azure for the TDD environment, and then of course the tests drop off for production. So you still have 3 running services, 3 running processes. We need information from all 3 funneling to the same place. In Azure, that's application insights, and then you also have log analytics that can pair really well. But you need them going to the same service. You don't want one application insights for your website and then a different application insights for your backend batch job and a different application insights for SQL Server. You want them going to the same service so that you can correlate them all together. And just by enabling application insights in your application, you're going to get a lot of normal logging for free and a lot of events when it comes to exceptions and things. And you're going to get a lot of metrics for free, just because Application Insights and Azure natively understands .NET, Entity Framework, a lot of the concepts and libraries there. But let's look at what happens when you intentionally design in events and then couple those with metrics. So in your databases, a lot of you probably are familiar with the Kimball method for data warehousing. And if you're not, write that down to look up. But if you've ever designed a star schema or even a fact table, which is the center of a star schema, then you understand dimensions and facts, which is a different way to design a data structure. And dimensions and facts are key to elevating logs to telemetry, because a dimension would be maybe the date that something happened, or a string. It's all the fields where you can, if you're going to do a query, you would do a group by on dimension fields. The facts are numbers. They're always numbers. And these are the columns that you would run aggregate functions on, like average, min, max, things like that. And so you want to emit those. Now, in an application, what we do in order just to build up records in our, in our figurative fact table, is for every single thing the application does, every transaction type, we want to emit a custom event to application insights. And you can even bake it into the architecture of your application if you use a CQRS pattern to create a request object behind every button click that a user clicks a button, and then you create an object which is effectively a user request, and then just pass that object through the application. You effectively already have a command or a query or an event in C# if you're using object-oriented programming like that, and then you can easily map that to Application Insights custom event object and record it that way. But if you do that, then you'll be able to add different attributes to it, which serve as dimensions, and you'll also be able to create custom metrics and emit those into Application Insights. So when you use that approach, the capabilities of Application Insights in Azure just come to life. They shine. If you're not using custom metrics or custom events, then you probably are not that impressed with Application Insights, because it's not any better than anything else. And so this particular example that I'm showing you on the screen right now comes from a car auction application. And you can see the dates, it was last summer. But the green checkboxes on the top are when there was a deployment to the production environment, and the bar charts show the number of events of the items that are checked. So you can see things that are relevant in a car auction: submit new bid, save buyer, register new buyer, and that's the general activity of a particular auction. And so we can see the system where there's multiple car auctions, but you can kind of see a rhythm or a seasonality where the weekends are, the system is doing a lot more than in the middle of the week. And you can also see throughout the summer, overall, the traffic was growing in usage. Okay, you can see those relationships. And then you can drill in, you can say, you know what, I only want to see when the system was actually taking a new bid. And you can check only that box. But these are custom events. These are because you're not just logging and saying, and using grep and text tools to try to glean this, or go to the actual production database to try to find this. You can see what's happening, and you can use line graphs, whatever you want. And then the green checkboxes on top, if you expected to fix something or a new feature, or you're improving performance, whatever it happens to be, you kind of expect some of the metrics or some of the events to change their behavior after a particular version's deployment. And so when you marry those two, you can see if that actually happened. And then if you hover on the green checkboxes up top, you actually see all the information about that particular release candidate, including a URL that can jump you straight over to that particular build of the software in Azure DevOps, and even tied to the commit in the Git repository that produced this build. So it really is powerful to link telemetry in with your overall environment. All right, that was a lot of information. I'll close any questions. And again, I'll leave my email address up here on the screen if anyone would like any of the resources that I mentioned. And thank you so much for having me at the re-kickoff of the Cleveland Azure User Group. It's fun.
Yeah, that elusive mute button, when you need it, you just can't find it. Thank you so much, Jeff. Highly appreciate it. And not just for the presentation, but also for offering an e-copy of the book. Much appreciated. And I will post a couple links in chat regarding some of the resources that we're going to go over. But before we do that, first of all, any additional questions for Jeff? Okay, let me go ahead and share my screen. So in the chat window, you'll see that there are 3 links. One is for the recording of tonight's presentation, which will be, the presentation will be edited and uploaded within the next 24 to 48 hours. And there's the link to the YouTube channel in the chat. Also a link for events, which we'll go over in just a minute. And last but not least, the eval form, so we can provide some feedback for Jeff. So let me go through some of the additional links that I have. All right, so with regards to the YouTube, again, the link is in the chat window, and if you subscribe to the channel, you'll get notifications once the videos has been uploaded. Also, the tech events, which we'll cover in just a bit, will be posted on my blog, and the eval reminder. As far as events, so on February 12th, which is in a few days, is Networking in Azure, and that is provided by the Toronto DevOps User Group. On February 17th is Serverless Solutions in Azure, and that is going to be next Thursday, and that is done by the Great Lakes Users Group, or GlugNet. And then on February 22nd is Azure Kubernetes, also done by the Toronto User Group, or the Microsoft Reactor in Toronto. And in addition, on February 24th is Azure Monitor, and that's also done by the Microsoft Reactor in Toronto. On February 24th as well in the evening, the Cleveland C# VB.NET User Group. Since many of us are developers here, we're going to have 3 authors from the new Pro.NET microservices in .NET 6. They're going to be discussing, what else? Microservices in .NET 6. So you'll get a chance to hear it straight from the authors. It'll be a combination of presentation / panel Q&A. They've been featured on a couple of podcasts, and I thought it would be great to have them in our user group meeting. Lastly, always like to thank TEKsystems for keeping jobs available on their website. In addition, I always like to ask casually, anyone hiring?
Yes.
Okay. Was that Jeff that I just heard?
Yes. Yeah, we got several openings at clearmeasure.com/careers.
Excellent. And what type of positions are you looking for there?
So architects and .NET engineers who are looking for a path to become an architect. US nationwide, 100% remote.
Oh, excellent. Okay, very good. And once again, that is clearmeasure.com/careers. Very good. Thank you. All right. Anyone else that's hiring? Or anyone else that's looking for work? Okay. So to close it out, my contact information if needed, if you have any questions, snasser@nastechnologies.com. And you can always find me on Twitter @SamNasser. And my blogspot, samnasser.blogspot.com. And lastly, I invite you to connect with me on LinkedIn. So if there's no other questions or comments, I thank you all for attending and look forward to seeing you next month or possibly at other user group meetings. Thank you all. Good night.